Winter is almost upon us, which means that some people are thinking about skiing. I'm not particularly one. I don't ski, but my brother is a ski instructor, so I know that some people really like to ski a lot. And we're going to use some of the tools we've learned in class to help someone decide whether or not they should buy a ski pass for the season. So let's assume our person has a demand curve for skiing where the quantity demanded equals 20 minus 0.5 times the price. And we'll think of the price as the price of a lift ticket for a day of skiing. This means that if the price was 0, if the ski pass was free, the person would go 20 times, right? 20 minus 0 is 20, thinking that for 10 weekends in the winter, they would go up and ski on both Saturday and Sunday. So it would be 20 days of skiing during the course of the winter if the ski pass were free. But the choice they have is that they could pay $200 a day for a ski pass each day that they ski, or they have the option of paying $2,500 for a season pass, meaning they can go up as much as they want during the course of the season. So let's help this person decide what they should do. Well, first of all, we can see that if the price was $200, right, the quantity demanded that they would have would be, the quantity of skiing would be 20 minus 0.5 times 200, which is 10. They would ski 10 times, and that $200 a day, their total expenditure should be 10 times 200, which they would be paying $2,000. And of course, if they buy the season pass, they'll ski 20 times, and the price they'll pay is $2,500. So we want to see which of these two options gives our potential skier the most consumer surplus. So remember, to do consumer surplus, we would like to see the graph of the demand curve, and we would like to then be able to calculate consumer surplus using the formula for the area of a triangle. So demand curve, of course, has quantity on the horizontal or x-axis and price on the vertical or y-axis. We know the quantity at price 0 is going to be 20, and we have to figure out what the number is that's going to be up here. Well, to do that, we realize that at price, the quantity is 0, so we just have to solve this equation. 0 equals 20 minus 0.05 times price. So if we add 0.0 times price to both sides of the equation, which you're allowed to do in algebra, we would get 0.05 p equals 20. We divide both sides by 0.5, and that's going to equal $400. So this point up here is $400, and of course we'll just have a straight line, and we've already solved that at the price of $200, which is the price of the daily pass, our skier is going to ski 10 times, and so we can calculate the area of this consumer surplus. 1/2 times 10 times 400 minus 200, which equals 5 times 200, which equals $1,000. So this person would get $1,000 of consumer surplus if they go pay the daily rate and go up the 10 times that $200 would indicate based on their demand. And if they get the ski pass, their marginal price is 0, right? So they will ski all 20 times. So it would be, we can add in the whole rest of this into our triangle. 1/2 times 20 times 400, because 400 minus 0 is 400, which is 10 times 400 equals 4,000. However, remember we had to pay $2,500 for the season pass. So we take the consumer surplus from the triangle, but then we subtract the what we had to pay to get to this big triangle, $2,500, and so our consumer surplus for the season pass is going to be $1,500. And since the $1,500 is greater than 1,000, we would say that the person should buy the annual pass, pay the $2,500, ski the 20 times, and they will get greater consumer surplus than if they just go on a day rate, pay the $200 a day, and only ski 10 times.